In this problem, we are given the graph of a transformed logarithm, and our job is to write an equation of this form whose graph would look like the one given. First, notice that a logarithm that has not been transformed would have a vertical asymptote at x equals 0, and the one that I'm using in this example, the vertical asymptote looks like it's happening at x equals -2. So it looks like we'll be needing to shift a non-transformed logarithm to the left 2 units. Let's explore this using Desmos.com. I'm going to graph y equals log x. So here's the graph of a base 10 logarithm that has not been transformed. To shift the graph to the left 2 units, change the input of the logarithm from x to x plus 2. Notice the graph got moved to the left 2 units. Also notice, however, that though my y-intercept is about 0.301, whereas my y-intercept seems to be much higher than 0.3. This is because we also have to define a vertical scaling for our problem. So far, all we've found is that the value of c must be 2. Replacing c with 2 gives us the following equation. So the fact that the model that we're using has a plus here and I replace c with positive 2 means you get a horizontal shift to the left of 2 units. Now I just need to find the value of a that will vertically stretch the graph so that my y-intercept is closer to 1 rather than it being at 0.3. So you may remember that if you put a number on the outside here, let me call it a, that if a is bigger than 1, it stretches the graph. My graph only needs to be stretched a little bit because its y-intercept is 0.3 and the one that I need is a little higher. So moving my slider to the right, making a larger, you'll see that my vertical asymptote will remain x equals -2, but it moved the vertical intercept up closer to 1. Not knowing exactly what the vertical intercept is, however, we need to pick a point somewhere on the graph that lies on the grid line. So if you're doing this question Math AS, hopefully you'll get a problem where the y-intercept is very clear. In this example, it is not. So the key to getting this question right is picking a point that lies right along a grid line. If you pick one that's only close, then you will not get the answer correct based off that point. So it looks like 4, 2 would be a good choice. That point looks like it lies right on the grid line, whose x value is 4 and whose y value is 2. So what I would do is I will take the point 4, 2, which can be thought of as xy pair. However, with my problem, they're not using y as an output variable, they're using f of x. So I will be replacing my output variable f of x with the number 2. I don't know the value of a yet because that's what I'm solving for. And I will be replacing my input variable x with the number 4. Since 4 plus 2 is 6, we can solve for a by noticing that the log of 6 is being multiplied by a. So I need to divide both sides by log of 6. And the log of 6 divided by the log of 6 is 1. And 1 times a is just a, so some people say that cancels. So I'm left with a being the number 2 divided by the log of 6. So if I were to just copy down the original equation, making no changes whatsoever except for putting in my value of a, we would get that f of x is equal to, this is where I take my a value and put it into this location right there. So that would be 2 over log 6, and then we have log of x plus 2. So you could type this into Math AS, make sure that you click preview to make sure the way you typed it in is correct. Or you could simplify your answer, and I'll show you how to do that in a second. But notice that this does fit the form that was originally asked in the question, where we replaced c with 2, and we found the value of a to be 2 divided by the log of 6. You should get credit provided that you picked a point right on the grid line and that you did your arithmetic correctly. Also notice that you could write this in the form a log quantity x plus c by changing the base. I chose to use a base 10 logarithm, but because you're dividing by log 6 here, you could have written your answer as follows. You could think of it as that your a could be just the number 2 if we change the base from base 10 to base 6, and doing so can be thought of as using the change of base formula probably in reverse of what you're used to. Math AS would also accept this answer as well as this. And notice that you're probably used to using the change of base formula where you're given a logarithm of some base other than 10, in this case 6, and you're asked to change the base by taking the log of this quantity and then dividing by the log of that quantity. And if you did that, you can see that you'd get from this equation to this one. Changing it from a base 6 to a base 10 would be log of x plus 2, which we have here, divided by the log of 6, and that's probably the way you're used to using the change of base formula. In this example, you could think of it as I did the reverse of that, and I changed it from base 10 to a base 6 problem. If you're typing this in MathAS and you do not have MathQuill available, MathAS would have you typing in the base of 6 by using an underscore on your keyboard that looks like that, which can be obtained by holding Shift and hitting the key on your keyboard just to the right of the number 0. Then you should be able to type the rest as follows, and MathAS would view that as being equivalent to this answer, and to see that you would hit the preview button. Let's go back to Desmos and take our logarithm that we shifted to the left 2 units and type in our vertical scaling of 2 divided by the log of 6 and verify that it goes through the correct point of 4, 2 as was given in our problem. So I typed in our answer to the problem. Let me hide it for a second. So comparing the graph that we were given to the one that we now have in Desmos, notice that both the graph given and the one that we found both have a vertical asymptote of x equals -2, and both pass through the given point 4, 2, which was given in the problem.